Horse and gents, welcome to UX, and this is Astronomy is in crisis. Astrology? No, it's astronomy. Yeah, it's incredibly exciting. That's science for you. Yeah, even the crisis is exciting. I don't know what it's going to be about. I saw a thumbnail about something star, but thumbnail changes. I don't. It's about space. It's about astronomy, astrophysics. That's my the topic when it comes to science. So I'm gonna have fun with this. Let's do this one.
Grab the 12,026 calendar and get it in time for the holidays. Our best theory of the universe could be wrong. Finally, we're going through an
Big Bang?
incredibly exciting moment. Thanks to amazing new technology, our understanding of the universe is moving faster than it has in years. And if we're fortunate, we could be at the edge of the next revolution in the way we see the cosmos. A moment as exciting as when we first realized that the Earth revolves around the Sun, that the stars are other suns, or that our galaxy is just one tiny island in an ocean of trillions. Why do we think this? Because for the first
Yeah, you know what? In Indian Hindu mythology, the god Hanuman, Monkey King, as you all know it, there's a verse. There's a lore. I don't know how to say that about like thousands of suns, and this is thousands of years old, much older than Roman Empire and Greek Empire. Back then, like obviously people didn't know, like Earth revolves around sun, and there are more suns. Well, they were saying like that, like for years we were like thousands of suns. What are you talking about? But now knowing like there are like millions and billions of suns, yeah, that feels more stronger now. I'm not making a point here. I'm just saying like how that age is, right?
time in ages, the universe is misbehaving. Badly. Nasty universe. For decades, we've had a beautiful theory of the cosmos. One that explained how the universe began, what it's made of, and how it's supposed to behave. It matched our observations astonishingly well and made us feel like we'd almost deciphered the cosmic code.
No, we
But in
didn't.
the last few years, as our telescopes got better,
This is a fun way of saying, but no scientists see it that way. This is like slowly uncovering the puzzles full knowingly. The picture might change in the future. When we know something like really like with confidence, like enough thing emerges, like yeah, Big Bang. Big Bang is not gonna be false. We might know something more that changes the picture, but Big Bang is going to be part of that picture. Just like Newtonian physics didn't really fail. It works where it's supposed to work. But it's just small part of like general relativity in what Einstein discovered, right? So we needed more. That doesn't mean Newton was wrong, right? So things like that, like what is established is not going to turn out to be wrong. Those headlines that say, oh, scientists realize they're completely wrong and they come up with something new. Yeah, that never happens. Only time that happens is like not enough study was like found in the first place, and the scientific truth that we know of wasn't really like established in the first place.
and our data sharper, cracks started to appear. Strange mismatches between what the theory predicted and what we actually saw. At first, they looked like silly mistakes, noise that would go away with more data. But as new data came in, the opposite happened. Some cracks got larger, new ones emerged, and our once perfect picture of the cosmos began to look less and less perfect. Of course, this wasn't new. 2 centuries ago, astronomers noticed that Uranus's orbit didn't quite follow the laws of gravity. But instead of throwing those laws away, they proposed that a dark planet was tugging on Uranus
Neptune.
from afar. Shortly after, Neptune was discovered exactly where the maths said it would be. But then came Mercury. Its orbit also didn't make sense, so scientists tried the same trick. But this time, no new planet
General
showed up.
relativity.
The answer wasn't more stuff, but a completely new idea. Gravity had to be reimagined, and we invented general relativity, opening a whole new dimension in our understanding.
There was also a time where numbers were like off. When a lot of observatories like observed a lot of things, numbers were completely off. So people realized there's even another planet beyond Neptune, planet X or whatever, which is even gargantuan. But then later on, they didn't they went with the Occam's razor type of mentality, like no way everything's wrong, no way Newton's laws are wrong. So they rechecked calculation and realized the calculation was wrong in the first place, and everything falls perfectly together. So the whole planet X things went away. Like, no, there's not another planet there because all numbers are fine.
understanding of the universe. So are we going through a Uranus moment or a Mercury one? First crack, cosmic monsters. The first signs that something deep could be off began piling up around 15 years ago in the form of a few seemingly impossible cosmic monsters. A giant arc of galaxies over 3 billion light-years wide. A massive group of quasars spanning 4 billion light-years. A ring of galaxies 5 billion light-years across. An unfathomable wall of galaxies stretching 10 billion light-years from end to end, a whopping 10% of the entire observable universe. The list goes on. That's not all. There are also monstrous voids, vast cosmic deserts with far fewer galaxies than normal. And according to some surveys, we happen to be living deep inside one of them, a gargantuan local hole 2 billion light-years across.
All right. I was in this year, I think, an astrophysicist in UK, I think, if I remember correctly, came up with this study, right? Published a study. English is not my first language, so don't grab onto the words I use. Okay, so like published a study, right? That we are part of, we are inside that void, right? When you see those models of like you zoom out, and you completely zoom out, you see observable universe, and it's like string type thing, right? And there are gaps in between those strings. The study said that we are in the middle of those gaps, not part of the strings where the matter is. Like we are in the void, apparently. Again, this is a study, not 1,000 study, which will happen in the future. Obviously, that's how science works, but it will take time. Nobody like tumbles over and like fund astrophysicists studies. No one cares at that level, apparently. So it will happen, but in the future. But this is like a study. This isn't like give you established truth at any length. Second of all, like we don't have observatories and like telescopes spanning across our entire solar system, from like Pluto, Neptune, one at the Jupiter, one at the Earth, and like we can collect the data collectively. No, we have a James Webb telescope. One of the telescope is like going away, and like there's no replacement for it right now. That's how fucked up it is, right? And others like obviously like X-ray telescopes that are on the ground and things like that. Our data is kind of limited by instrument itself. One of the reasons, string theories, right? String theories are failing because we don't have means to test the things they're coming up with. We don't have means of instruments, right? We don't have like particle accelerators at the size of the moon and shit like that. So we are physically limited in many things. So when we see these gaps, when we see these voids, I believe that we don't have enough data, right? Even with our best observation, there are things that are missing just by us being there. And this could be one of those things. We are in the middle of the void because we are observing from that and we are seeing it as a void. And there could be a lot of voids in this picture, right? The observable problems. Now, obviously, people say, like, what you talking about? We can see the next star. We can see exoplanets that are close by. No, it's about contrast. When we go at these larger scales, we need more data. And maybe just because we're in the middle of it and we're trying to observe, we could literally not see certain details that we could have. And there are real restrictions that are, like restricting our point of view. That is creating these voids. Maybe they are not voids. There are many things like that, right? Like Andromeda, right? Andromeda is going to collide with Milky Way. Great. We can see Andromeda at the southern hemisphere if you go to Australia or something like, or South America or something. And we see this like Andromeda as a blotch, as a bright thing. When Andromeda will come really close to Milky Way, where it's like half of the sky it covers, we won't be able to see it. Our own stars, our own Milky Way things will be either equal or more brighter than that. It will just blend in. Like you won't be able to tell where the Andromeda is. Something like that. Because we are observing from here, things that are close to us might not be visible enough. Like closer thing might be, like obstructing the view in a certain way. Could be something like that. So one study is not enough, right? This doesn't really change something at that scale. I'm sure like Kurzgesagt will come to the similar point in the end.
Ross, where's the problem? Well, the universe is organized in ever larger structures: galaxies, galaxy clusters, superclusters, and eventually filaments, truly gargantuan structures separated by equally enormous voids. But our cosmic theory says that these things can't get arbitrarily large. At distances beyond 1 billion light-years or so, the filaments and voids should blur into a uniform soup. And this is more than a technical detail, it's a basic pillar of all our attempts to make sense of the cosmos itself. Our understanding of the universe rests on one key assumption: the cosmological principle. This is the idea that if you zoom out far enough, the universe should be uniform, looking the same everywhere.
Granular.
This is crucial because it means that our
Granular.
limited view of the cosmos is a fair sample of the whole. That even if we are tiny creatures living in a speck of dust, we can learn things about the entire universe. Both the cosmos itself and our place in it might be more unruly and chaotic than they should be. But if the cosmological principle turns out to be wrong, we have a huge problem. Because if the universe isn't the same everywhere, we could be like ants trying to guess the flavor of a cake while sitting on its only cherry. Everything we see might just be local weirdness, a cosmic quirk that doesn't tell us the actual
Yeah, we are assuming granular universe basically is equal. Like our own 3D universe might not be equal outside. Like it might have curves and basic things like that, right? But right now we are assuming it's like uniform in all directions. That might not be true. See, we are at such a smaller scale that we are talking about such a larger scale thing. It will take time for us to realize all these things. But yeah, if it turns out like this is all like not the way we thought, yeah, the fundamentals of things kinda falls apart. We need to think about it in a different way.
story of the universe. Second crack, a universe at 2 speeds. The next crack appeared about 10 years ago. It tore straight at the fabric of space, challenging how fast it grows. Every second, the universe gets a little bigger. We know this because we have different ways to measure it, and all confirm that space is expanding. The problem, they can't agree on how fast. It's like measuring the speed of a car using 2 devices and getting different results. You read 67 on the speedometer, but 73 on the GPS. One of the instruments must be broken, right? But then you check them again and again and again, and both work flawlessly. This is very much what happens with the universe. The details are messy and complicated, but they don't matter for this story. The important part is that as measurements and calculations have become more and more precise, the disagreement has only become worse.
Yeah, usually in practice, if the measurements are like linear, like even though they're different, they're linear in their own way, whatever we're trying to implement doesn't become a problem. But the more like details you go on, that will become a problem. I'll remember watching, I think, Veritasium video about like light speed. Nobody knows the light speed. Why? Because you need to measure it 2 ways. And how do you do that? How do you know that it's not going half a speed at the other direction and instantaneously in the other direction, right? How do you know that? You're measuring that way. So how do you know the speed of light? How do you know when the light left here and went right direction and came back to the left direction? How do you assume those both directions are equal speed? Maybe it goes half a speed here, maybe double speed here. You never know that. Obviously, like common sense, like why would that be the case? But that's not how science works. So shit like that.
By now, the chance that this mismatch is just an accidental fluke is less than 1 in a million. The universe is literally giving us 2 different answers to the same question. So something fundamental must be broken. Either our measurements of the universe or our basic understanding of it. Third crack, old galaxies in a baby universe.
Usually science go with like a simplicity answer, like rather than saying the whole world is broken, probably your observation is broken. So science usually go that way. Like maybe we need a better way to like understand it rather than think the whole universe is weird.
The latest surprise is only about 3 years old. It shattered a key part of our cosmic timeline, how and when the first galaxies formed. Telescopes act like time machines. Light from distant galaxies takes so long to reach us that we don't see them as they are now, but as they were in the past. In 2021, we launched the James Webb, the most powerful space telescope ever built. And almost immediately, it began finding bright, massive galaxies so distant that they belonged to a time when the universe was extremely young. The problem? Some are so premature that they date back to 280 million years after the Big Bang, far earlier than anyone expected. Our theory says that the amorphous soup of matter that emerged from the Big Bang gave rise to the first galaxies through a long chain of mergers. Tiny lumps of dark and normal matter gathered under gravity, building larger chunks that then fused into even bigger ones, and so on. But this process is lengthy. By our best estimates, the first large galaxies should have emerged 500 billion years.
Yeah, this to me feels like some of misunderstanding of information that maybe we'll realize one day in the future. Like early times, like how everything was condensed, right? Certain properties acted differently.
Years after the Big Bang, or so, not much before. But it isn't only that we found large galaxies existing way before that. The new galaxies also seem to be too mature. Matter in the baby universe was made up almost entirely of hydrogen and helium. Heavy elements like carbon or nitrogen were only forged later in the cores of stars, which had to explode to release them. But some of these super early galaxies contain a lot of heavy elements, meaning that entire generations of stars must have lived and died even before them. So,
Yeah, like I said, the galaxy was much more condensed. We don't know how the processes work. Maybe we'll realize one day, like the things were accelerated. Stars exploded pretty young than they should have by fusing elements pretty faster. Like we're talking about like something we don't know about. So like this all might sound stupid. Like what you're talking about, that's not how anything works. But you don't know what we'll like realize in the future.
this is like finding grown-up kids in a kindergarten. Either the first galaxies sprouted in fast forwards, or we're missing something huge about the infancy of the universe. From cracks to crisis. These problems aren't the only ones. Our theory also says that the Big Bang should have created 3 times more lithium than we see out there, a decades-old itch that astronomers just can't scratch. It predicts that dark matter should pile up sharply at galaxy centers, but instead we find gentle hills. It says that dark energy, the mysterious force pushing the universe apart, has stayed constant since the Big Bang. But last year, one of the biggest galaxy surveys ever conducted dropped the bombshell that it may have been changing over time. If true, this would overturn our current picture of the universe, its past and its future. Even things that we consider
Our superpower is linearness, right? Like accumulation of, like knowledge and things acting the same way. That is our superpower. That is how we basically dominate things. But when the randomness enters the chat, like, okay, things might have evolving left and right. What we can predict right now, that might not have been the case in the past. Like, how do you predict that? Oh, shit. 3-body problem type of thing. You can't really solve 3-body problem, does it? Because, like, 2, it's fine. 3, holy shit. Things like that. Like, just at the level, at the third one, it became true and predictable, right? Something like that. So, when we realize that things are not the linear the way we thought, if this means this, then this also means this, and that's how it goes. And we can predict shit all the way from 13 billion years. Maybe that wasn't the case. How do you solve that? How do you understand that? How are you going to predict things? Which supercomputer will create a model that might be accurate enough?
that had settled beyond any doubt, like the interpretation of the cosmic microwave background, are suddenly up for debate. Those early galaxies might have been bright enough to contaminate the signal. These are bold claims that require much more evidence, but the mere fact that such fundamental pillars are being discussed is staggering. So, okay, what does all this mean? Right now, there are furious battles going on. Some scientists argue that these aren't real cracks, but mirages that will disappear with time, or raw gems that will end up refining our theories.
Yeah, I'm also in that camp, or rather I should want to be in that camp, because like I said, usually how science work is like you don't just throw away everything you learned, or like everything's wrong. That's not, like I said, Newtonian science doesn't turn out to be false. Something else gets layered on top of it. The thing we know, that we know of, maybe that's not the whole picture. Maybe there are holes in that we didn't know of, but that still is not going to be false, because enough data is there. Like, it can be wrong 1 time, 2 times, not 100 times, not 1,000 times. After 1,000 times, it's right enough to be right. So I'm in that camp, like this maybe are somewhat of a mirages or part of the larger truth or the way of thinking that we don't know about.
Others are more radical and say we need completely new ideas. But whatever the case, the big picture is
The people who say like tear the shit down and rebuild it, that mentality, I'm never with that. Like, really? you're gonna tear down everything and like rebuild from the scratch because everyone was wrong before somehow, and like we need to think completely different. That could be true. Chances are very low. And if that's true, we are probably gonna fuck it up. If we're gonna like it will take time. Like science wasn't slow back then because we didn't evolve. Science was slow back then because they didn't have any fundamental to start with. They were the fundamentals. Science can progress somewhat faster now because we have those fundamentals. But if we have to start from like, okay, well, everything's wrong, let's think about astrophysics in a different way. Yeah, that shit's gonna take a long time.
Difficult to ignore, the sense of crisis is growing. And for the first time in ages, we don't really know what cosmology will look like when the dust settles. Which is amazing because in science, crisis doesn't mean failure. It means that the machine is healthy and working. Science doesn't move in a straight line, but in cycles, periods of calm followed by sudden crises. When a crisis hits, experiments start giving results that don't fit existing theories. Confusion grows and strange ideas pop up. And eventually, there is a revolution. A deeper truth emerges and a new cycle starts over again. The universe is screaming that our story is incomplete. Whether we'll find a cosmic Neptune or a cosmic Mercury, one thing is certain, the cosmos is about to get a lot more interesting. Science.
Yeah, people, go to original page link and from there support this channel. Look, man, like I said, there was a time people were finding planet X because finding showed something is missing and Newtonian physics is not working. There must be another planet there beyond the Neptune, which is not Pluto, but something really bigger, gigantic, much bigger than Jupiter. Yeah, it turned out that Newtonian physics was not wrong, and just like our data was off. That is at the small scale. This is at a larger scale. Well, like the Kurzgesagt said, this might be mirages at certain level. Look, if there are multiple papers which suggest this, I'm like, yeah, we're in trouble. This is one paper from I think June or something this year by a UK astrophysicist who just like put out, right? Which is like a credible thing, but that's not how science works. You need more papers than just this. So this is something to worry about. Yeah, James Webb opened more eyes and more things we are learning, but we'll adapt to it. We'll realize like how this add to the science. I'm not in the camp who like, oh, everything is wrong. We need to think about it from the scratch. String theorists were basically there. Let's tie everything in one theory. String theory. That didn't work out so well. String theory is like dead in water somewhat. Like I said, people say like, yeah, we need bigger instruments and we are making progresses. Yeah, maybe 1,000 years from now and we realize string theories were right. Who the fuck knows? But usually that thing doesn't end well. Like, let's just tear down everything and build from bottom. Yeah, that's not going to work. Alright, well, if you like my next one, don't forget to subscribe and I'll see you next time.